Welcome back, everybody. I'm so glad to see you. I knew you would come see me on this problem. This problem is fun. It's kind of fun. So let's go ahead and have some fun with it. What we've got is a small circle inside a larger circle, and we know how far it is in this larger circle from here to here. We also know how far it is from there to there. It's 3/14. We'll just say of an inch. Might as well say inches. We don't know how far it is across what's called the diameter, by the way, of the smaller circle, all the way across it. We do know that the diameter all the way across the larger circle is 6/7. So with this information, what we're being asked to do is find what's this distance right here. What's this distance right here? Well, let's see what we can do. I wonder for a second, just kind of stepping away from that, just using your own intuitive abilities here, if you had a similar problem, only your similar problem, it didn't have fractions in it. Let's say that this distance right here was 5, and this distance right here was 5, and the whole distance right here was, I don't know, let's say it was 17. I wonder if you could guess how far that is. How far that is. I ask you that because the strategy you're going to use to get this one is the same strategy you're going to use there. Only difference is those are fractions, and I know fractions just kind of mess with you a little bit sometimes. But I wonder if you could look at this and kind of tell, well, you know, all the way across there's 17, and that's 5, and that's 5. So, I'll bet to make that work, that would have to be 7. That would have to be 7. Your strategy would have simply been to say, okay, the 5 plus the 5, of course, is 10, and then 17 minus the 10 is 7. In other words, to get all the way across here, we take the whole thing across and subtract out the two pieces we know to get the piece we don't know. All the way across, subtract out the two pieces we know to get the piece we don't know. Let's take that over into this other problem and use that same strategy. So, to get this piece right here, if we take this and add them together, 3/14, 3/14. And then we take that answer of those two and subtract it out of this, I think we'll have an answer. It's the same strategy we used on the one with whole numbers. So let's go ahead and do that. Now these are already like fractions. We can just simply add them. 3 plus 3 is 6/14. 6/14. Okay, cool, 6/14. Then how about we do this then? We'll take our 6/14 after we add those, and let's subtract that from 6/7. All right, so 6/7 minus 6/14. Now, what we've seen before, in order to subtract these, we're going to need a common denominator. Common denominator for 7 and 14 certainly is 14. That stays a 14, so this will stay a 6. Remember, when you're doing this, if the bottom number stays the same, the top number stays the same. Now, the 7 here became a 14. To do that, it had to get multiplied by 2, and so the 6 times 2 is 12. All right, so I think we're ready now to do our subtraction. 12 minus 6 is 6/14. Now, we'll want to simplify that, and when we simplify it, divide by 2 here, divide by 2 here, and I think we'll get 3/7. And so our middle piece right here, our question mark, ends up being 3/7. Once again, to review that strategy, simply add this side and this side to see what the two together are, and then take those two and subtract them from the distance all the way across here, and you'll have your distance that's missing in the middle. I hope that's helpful to you, and I will see you again next time.